So here we are with the mole diagram, the very famous mole diagram. And it's very, very helpful to think about this diagram when converting from moles to grams or grams back to moles. Notice this double arrow. And to convert from moles to liters or volume and back to moles from liters. And also converting from moles to the actual number of stuff or back and forth. So there's three important types of conversions you have to understand. The first one is that a mole represents a number. This number is 6.02 times 10 to the 23. It's a huge number, hard to even comprehend. But if you had a stack of paper, a mole high would go to the moon and back 80,000 times. It's hard to understand the size of this number. And the reason why it's so big is because we're dealing with things that are so small. But it's this number of particles that will fit into 22.4 liter box if that box is under STP conditions, standard temperature and pressure. That's the number of seats in the theater. A lot of seats because they're so small. Now, if I want to know the mass per 1 mole or per number of seats in this theater, the converting factor is not so easy because I have to go to the periodic table and actually calculate it. But if I want to go from a mole to liter at STP, it's always going to be 1 mole is 22.4 liters. Well, because we made it that way. We decided some quantity of molecules that fits in a 22.4 liter container will equal 1 mole. And we chose that because we wanted to make our gram ratios when we did relative masses between atoms to be whole numbers. But let's get right to it, because I know some people are having a difficult time trying to convert from one to the other, but this is your friend. And I can't say enough why moles is the most important concept, bar none, in chemistry, because it gets us to discussing the actual number of stuff that we need. Hey, one hydrogen molecule, H2, two of these hydrogen molecules collides with one O2 molecule, right? And what does it make? It's going to make 2 water molecules. Conservation of mass. The mole concept led us to figuring out the number of what? Atoms to other atoms, the ratio in chemical what? Formulas. So all of this got us to the ability to write chemical formulas. And H2O means you have twice as many H's as oxygens. That's why it looks like this, so that's why we write that. Doesn't mean twice as heavy. This mole stuff is a how many number, and we're going to use it exclusively all year. But let's get to some conversions, okay? So let me just make some things up here, and you can follow along, okay? So let's do that. All right, so let's make a question up. Let's say my first fictitious question, I guess it's not fictitious because we're writing it. Let's say I have 2.37, 2.3 liters, let's make it that, of hydrogen gas, and I want to convert it to grams. Okay, I'm starting you with 2.3 liters of hydrogen gas. Of course, it has to be at STP. They'll say that in the problem. If it doesn't, you can't do the problem, okay? But look at our mole diagram here. We're going from volume to grams. I'm starting with 2.3 liters, and I want to go to grams. So obviously, we have to convert to moles first and then to grams. So how do we do this? Well, the first step, write the number that's given to us. This is just a straight conversion. We've done conversions before. So 2.3 liters. I know that I have to go through moles. How do I know that? Because it's the mole diagram. Volume has to go to moles, and then moles goes to the mass, or the grams. So I convert to moles first. I get rid of liters. Liters, of course, goes in the bottom. And I know that 1 mole of any gas at STP is 22.4 liters. That is always the case, and that's given to you right here. No matter what, doesn't matter what the gas is because volume is proportionate to how much stuff you have. It doesn't matter. Okay, it's Avogadro's law. Okay, now what cancels? Well, liters cancel, and I'm left with moles of my hydrogen gas. But that's not my answer because I was asking you what's the gram. So we went from volume to moles. Now we got to convert from moles to our mass. Now what's the converting factor for moles to mass? Well, it depends on the periodic table. So let's set our problem up. I have moles of H2 here. So the second step in the problem, I'm going to get rid of moles. Now 1 mole is equal to how many grams? Well, just like my mole diagram suggests, I have to go to the periodic table. Let's go there. And here it is. And let's go find our H. Let's zoom in. Let's get up close and personal. And we can see, party people, that hydrogen has a atomic mass of 1. You can round. And if you're not sure what number is the mass, okay, if you look where it says key, the top number, the number that has a decimal, is the 1. Now the one in class that we used has a decimal, but it's written below. The general way is to write the atomic mass above the symbol, but if you don't know which one you're using, use the one that has the decimal place. That's the atomic mass. So back to this. Each hydrogen has a mass of 1. What does that mean? Well, if I've got a box of hydrogen, 22.4 liters of it, at STP, it weighs 1 gram. Okay, well, guess what? In each seat of my box, I've got what? 2 H's. So there's 2 moles of hydrogen per box. So therefore, it's 2 grams. But let's go back to our problem. So we do a formula mass, and the best way to do it is like this. So we have H2, which means you have 2 H's. And watch what I do here. 2 times the mass. This 1 right here, I get from the periodic table. We just got it. So this is 1, I get this 2 H's, so 2 times 1 is 2. And this means 2 grams for every mole. So this becomes 2 here. Again, each H was 1. Because I have 2 H's, I times it by 2. And now look what cancels. Moles cancel, and now I have grams. So take my trusty calculator, okay, and I multiply the following. 2.3 times 1, divide by 22.4. Sometimes it's helpful to just hit enter there. And then times by 2, enter, and divide by 1 if you have to. And what you get, party people, is you get 0.2053, and the only unit left standing is grams. And that's how many grams of hydrogen would fill up 2.3 liters of a gas at STP. It's a 2-step problem. Now, of course, I started with how many sig figs? 2, so my conversion should end with 2, so I really should have 0.21 grams of hydrogen. Okay, so all we did was this first part, we converted our liters into what? Moles. And then we took a moles and we converted it into grams. That's the second step. All right, let's do another fictitious problem. Okay, what if I have 300 grams of, let's make it sulfur dioxide, SO2. All right, how many liters does it occupy at STP? So I'm asking you to convert 300 grams of SO2 and say how much space does that take up if it's flying around a gas at STP? Well, like all conversions, we start with the number given. So I write 300 grams. Okay, and the first step, notice we're going from grams to liters. So go back to our mole diagram. Oops, go back to our mole diagram. We're going from what? We're going from grams and we're converting to liters or volumes. So we're going to convert our grams, which is mass, into moles. Then moles into volume. It's a 2-step problem right there. So let's do that. So I get my 300 grams, I have to convert to moles. I'm always converting to moles because the mole is in the middle. All right, monkey in the middle. I'm always going to moles first. So when in doubt, convert to moles. Very famous line when you're studying chemistry. So grams go on the bottom, and 1 mole equals how many grams of SO2? Well, I've got to go to the periodic table to get that conversion because I have SO2, so I have to come up with something called a formula mass. There's 1 S and there's 2 oxygen atoms. So we need the mass of the S and the O. So let's go to the periodic table. Going there, let's make it smaller, sulfur and oxygen on the other side. And let's get up close and personal over here and zoom in and get over here. And there's my sulfur and there's my oxygen. And so sulfur is 32 grams per 1 mole of sulfur atoms, and oxygen is 16 using the decimal point. So loaded with that information, now I can figure out the converting factor. All right, let's go back to our problem. So I've got 1 sulfur, so 1 times 32. I got that, I rounded that, so that's 32. I have 2 oxygens. 2 times each one from the periodic table, atomic mass is 16. That gives me 32. And I add them together, and I get 64 grams per mole. All right? And of course, that 64 is here. Remember, going from mass to moles, or moles to mass, that converting factor depends upon what is in the seat, okay? How heavy those atoms are. All right, so back to our problem. So I get rid of grams. This gives me moles. But where are we trying to go? We're trying to go to liters. So we times it. We get rid of moles again. We go to liters. And what is the converting factor? Doesn't matter. Doesn't matter what the gas is. It's 22.4 liters equals 1 mole. Okay, I want you to understand something here. In this part, we converted to moles. This part, we converted to liters. Two-step problem. And all we were doing was going from here to here. But we needed the formula mass. We had to add those atomic masses together. Okay, let's go find that answer. So I take my 300 and I times it by 1, divide by 64, times by 22.4, and what I get is I get 105. 105 what? Use your units. I get 105 liters. So 300 grams of sulfur dioxide at STP will occupy 105 liters. Okay, and that's how you do that. Now, if you notice, we kind of skipped, number of stuff. So let's do one with that. Let's go from grams to number of stuff. Let's go grams of something to the actual number of molecules. Okay, so in this problem, okay, this will be number 3, fictitious problem number 3. Let's start with 100 grams of, let's see, hydrogen sulfide. That's H2S. And I'm asking you to convert that to the actual number of molecules. Some people don't know when you use 6.02 to times 10 to 23. And you use it if I'm asking for the exact number of something. How would I say it? I would say something like this. If given 100 grams of hydrogen sulfide, how many molecules is that? You notice I'm not asking for moles. I'm asking for the actual number. Well, the actual number is going to be tremendously big because these are so small. So what do? I start with my grams. And if you look back in your mole diagram, it's your friend. You go from grams to number of stuff. I've got to convert to what first? I've got to convert to moles. I'm always going through moles. And then from moles, we go to the actual number. So to go from mass to moles, I've got to use the periodic table to figure out my converting factor. So I write down what's given to me. I've got 100 grams. If I make that 100 point, say I have 3 sig figs, of H2S. Okay, well, my friends, I'm going to get rid of grams to get to moles. I've got to go through moles. All right? Now, the problem is, how many grams is it? Well, we have our H2S molecule. We're going to have to figure something called the formula mass out. There are 2 H's and there's 1s. Okay, we go to our periodic table. Remember, our sulfur is already 32, and if your short-term memory is gone, mine is at my height, okay, you see that hydrogen has a mass of 1. So loaded with that information, we go back to our problem, and we know that our sulfur, there's one of them in the actual molecules, so 1 times 32 gives me a 32. That's the mass for all the sulfur atoms, okay? And then we have 2 H's. Each H we just did is 1. We're rounding that number. It's 2. Add them together, and our formula mass is going to be 34 grams per mole. And that is what goes here. That's our converting factor. It's always going to be different because different molecules have different atoms, and different atoms have different masses. Okay? Now, I went through moles. The next step is what? Well, if I'm getting the actual number of stuff, I just went from mass to moles. Now moles through the number of stuff. I have to go through this conversion. And just like 1 mole is 22.4 liters for every single gas at STP, 1 mole for anything equals 6.02 times 10 to the 23. So, get rid of moles. 1 mole is equal to how many molecules? You better believe it's a big number, 6.02 times 10 to the 23, and that's the number of molecules. Don't confuse that with moles. All right, notice the moles cancel, and I'm left with the actual number of molecules. Let's go find that number. 100 divided by 34, all right, times 6.02. I like to use, if I'm using a Texas Instrument calculator, do the second function, hit the EE key, and type in 23. All right? E to the 23 is 10 to the 23. And then I hit enter. Okay, if you're using the caret key, you have to use parentheses. That's why I'm not a big fan of the caret key. So you should get, if you're doing this correct with me, with your calculator, you should get 1.77. Now, don't forget the rest. If you leave it like this, it'll be wrong. You're forgetting a lot of zeros. Times 10 to the what? If you see 1.77 e to the 24, it means 10 to the 24. And of course, the unit is molecules, right? It's not moles. Okay, mole, if you remember, is a what? A word that describes a big number. Just like a dozen represents 12. So molecules is not mole. It's a big number. Okay, and that is your answer. All right, and that's essentially how you do these. And if you can handle these, there's nothing I can give you that you cannot figure out yourself. Now I'm going to do one more type of problem, but it's not really a conversion. It's a ratio problem. Number 4. Let's say I have the following. Let's say I have glucose, C6H12O6. Okay? Now, here's my question. If I have 1 mole of glucose, right? And I should do this way. Mole of glucose molecules. 1 mole of glucose molecules. Question is, how many carbon atoms? Now, careful. If I say how many carbon atoms, what I'm mentioning is the exact number, okay? If I say how many moles of carbon atoms, that's different. I'm going to handle both questions. Let's do the first one. How many moles of carbon atoms? If I have 1 mole of glucose, how many moles of carbon atoms? It's a big difference. Well, if I've got 1 mole of glucose, doesn't that mean I have 6 times the amount of carbon atoms? Right? There's 6 carbons per one of these. So if I got a mole of these, I've got 6 moles of carbon. So the answer would be 6 moles of carbon. Right? Now, if I said to you how many carbon atoms, then I would have to take the 6 moles and times it by 6.02 times 10 to the 23. Okay? And that whatever that number is, because I'm asking for the actual number. So that's a ratio question. And we'll do another just so you can find it. Maybe I'll do a much easier one. Okay, we'll do one more so you get the idea. So let's take this. Let's take C3H8, propane. If I have 1 mole of propane, how many moles of hydrogen atoms? In one of these, how many H's do you see? So in 1 mole of C3H8 molecules, you have what? 8 moles of hydrogen atoms. If I said to you, how many hydrogen atoms? Not moles, how many? The answer would be 8 times 6.02 times 10 to the 23. Big difference. Okay? If you're still a little iffy about what I just did here at the end, no worries. Okay? I just kind of threw that in. But I need you to understand the first 3. Okay, please do those 5 or 6 questions I have for you.